Okay, should we start? Well, thank you for coming along and thank you for inviting me along to the event as well in Riga. I think I came here about 6, 7 years ago before, and so it's been a lot of changes since I was here. Still snow though, so that's good. My name's Mark, and I'm going to talk to you today in this session about how the Hadoop platform has evolved amazingly over the last few years to the point where I believe that every every developer working on analytics projects and data warehouse projects on the Oracle platform will almost inevitably be using this in the next couple of years or probably be out of a job. Because I think that my view is that every analytic and data warehouse workload will move to this platform over time because of the economics, because of the innovation, and because of the kind of the energy behind it really. So what we're going to do is kind of start off by going through a little bit of history. I assume really that anybody in this room now and anybody really in our industry has a kind of basic idea of what big data is in Hadoop, so I won't spend too long on that. But what I want to do is go through and dispel a few myths really, and talk about some of the innovation that's happening on the platform, now. And one of the challenges really with doing this kind of talk, and I was explaining a moment ago, is the pace of change. And it's almost like Oracle releasing a version of the database, 8i, 9i, 10G every 2 or 3 months, which makes it a challenge writing presentations on this because you virtually have to rewrite it every time you do the presentation. So I was in my hotel room yesterday all day until 2 o'clock in the morning, just kind of updating the presentation for today, which makes it interesting as well, but quite a challenge to stay ahead of it. So my background actually is in analytics and data warehousing. I've been doing this for a while now. I wrote a couple of books, but actually in the last kind of two or 3 years, my kind of main focus has been on big data, Hadoop, and so on really, and working with my customers and my company to kind of move customers onto this new platform and use it to complement the traditional strengths of an Oracle data warehouse. And everybody is talking about big data at the moment. It's the kind of big topic. Everybody's on about it all the time. Data scientists are sexy, which is kind of good. Gives people like me hope. Now being 48, that suddenly I'll become sexy. Which would be good. Although I need to have a beard, obviously, to do that. But everyone's talking about it, and it's kind of big news and the topic of the moment. To the point where actually people kind of get sick of hearing about it. It's big data this, big data that. And I think that we tend to focus a lot on these kind of, use cases to do with kind of Internet of Things and sensor readings and so on. But again, my analogy here with other things is to say that it's like the space race. There were lots of technologies that came out of the space race and putting man on the moon and so on, upside down pens and kind of, freeze-dried meals and all these that, you don't need to go to the moon to get benefit out of really. And with the big data revolution, there's huge amounts of technology and innovation and spin-off things that we can just use in data warehousing and BI and analytics as well. Okay, so that's the kind of background to what we're doing here. And I suppose really for anybody in this room, why is Hadoop, why is big data of interest to us? And I'm assuming that most people in this room are probably data warehouse developers, BI developers, or just general developers working, on projects around kind of traditional technologies, but they need to have an element of kind of analytics and so on in there really. And there's a number of kind of reasons why we'd be interested in this. First of all, one of the kind of classic things you do in data warehousing is you kind of load data, you aggregate it, and you throw the detail away. Which means all we ever have from that point onwards is aggregate data, the average for all customers or the kind of total sales for the store, but losing the detail. What Hadoop allows us to do, as you know, is to store detail and keep the detail. The other thing is very cost effective. We can sort of like scale out almost infinitely. The cost is so cheap, but also there's an amazing amount of innovation going on around Hadoop, and that for me is interesting. I mean, I've worked in kind of BI and analytics now for kind of 15 years. There's only so many dashboards and graphs and kind of like aggregate tables you can take after a while. But the amount of innovation that's going on and the different ways we can analyze data is very interesting. And I'm actually doing 3 sessions at this event over these days. So the one I'm doing this evening at 5:45. If anyone makes it to that, I'll buy you a beer because it's quite a late sort of session. I'll certainly need one anyway. It is around using data reservoirs and data lakes and a tool called Big Data Discovery. So we'll see how that works. And then I'm doing a workshop tomorrow where I'm going to look again about the detail of how we do this. I'm going to look at things like graph analysis. So how can we take all the tweets about Oracle publications? So I've been capturing, I know Chris Saxon's in the audience, so I've been capturing all the tweets that mention Ask Tom, mention kind of OTN, mention OTN Archbeat and so on. Been capturing those. That's actually why I missed the meal on kind of Wednesday night. That I was just kind of I'd captured all these tweets and I was trying to put them into Oracle Graph and Spatial, which I thought would take about 10 minutes and took me about till 2 in the morning to do. But I'm going to show you that on the Friday and show you how we can do things like graph analysis and sentiment analysis and how we can work with data, put it into HBase and so on, and do some kind of big data analysis. So there's some kind of very interesting things going on with that. So, and this is, I guess, again, just kind of background. Why is Hadoop and big data so kind of interesting? Well, it's this kind of flexible storage, cheap storage for storing data that isn't kind of tabular. So typically you don't take data out of your business suite and load it into Hadoop. I mean, you could do maybe as an archive or something, but that's not really kind of where the strength is. It's about taking data from kind of events, from logs, from social media, all these kind of non-traditional data sources, ingesting them typically in real time, as we'll see in a moment, storing them in file format or increasingly now in things like the cloud, so object storage in the cloud, so S3 or Oracle Cloud Storage, and then using these new types of applications to understand and analyze the data. So these are all the kind of things that we're finding Hadoop is used for at the moment, Hadoop and big data. And then what customers are asking us to do now, and what we're working with customers on, is using this technology to complement kind of traditional data warehouses. So that the classic, I mean, I always say the Oracle salesman's dream, or certainly the classic kind of, you've got everything kind of stack really from Oracle, is to have an Exadata and a big data appliance and potentially an Exalytics. And we store them, we hold them together. We use InfiniBand between the two things to move data between them. We use Hadoop to do the kind of the change the business style work. And we use Exadata to kind of run the business and do kind of to analyze the most important data, store it over time, index it, summarize it, and so on. So these are the kind of uses that we see. And most projects that we see now, although they're innovative, they tend to use, and we'll come back to this in a moment, MapReduce as the underlying kind of mechanism for moving data around. And we'll come in a moment to the strengths of that and the weaknesses of it and so on as we go on. And then in terms of data warehouse, data models, most of you are probably aware, if you work in analytics and data warehousing, of the idea of a 3 sort of layer data warehouse. So you've got your staging area where you load data in, you might go and do some cleansing, might do some kind of combining and so on. You would then have a kind of like an ODS or a foundation layer, which is your long-term store of data, which is stored in a query neutral kind of form. And then you've got what we call the access and performance layer, which is where you have your star schemas and your OLAP cubes and so on. So the way this has evolved over time now is that we typically recommend this common model to customers now, where I don't know if this has got the laser thing here. It has, right, brilliant. So what we do here is we have different data sources coming in, as we traditionally have into a data warehouse. But then we have a choice then about how we load the data. So we might load the data in raw form into Hadoop. So it might be logs, it might be kind of files, it might be just kind of data via, from an Oracle database via Golden Gate. And it goes into that kind of raw area there. And the kind of width of the triangle here is meant to illustrate the amount of work that goes in to get it into that area. So if it's going into a raw data reservoir, yeah, it doesn't require much work. You just copy it in and that's it. If it's file landing, it just be copying a file in there. If it's using, say, Golden Gate, you're just copying the data in as it stands. But then to get value out of that data, it takes more work because you haven't done any kind of like cleansing, any standardization, any kind of work on it, any summarization or whatever. Or you can land it into, say, a foundation area, which is like your third normal form area, or land it into the access and performance layer. And you can move data up this thing as well. And then this again shows you the kind of relative difference in getting the value of data out of it. So this is, again, background as to what we typically advise customers on at the moment. And so that's the kind of typical data warehouse data model that we use. And then it can be deployed on any kind of Hadoop platform. Now, a lot of our customers use Oracle Big Data Appliance because it's pre-configured, it's pre-installed, and all this kind of stuff. Other customers would use a commodity kind of Hadoop cluster. Back home, I've got VMs and stuff running at home. I just run things on commodity servers in the garage. If you use Big Data Appliance, there's various benefits and so on, but I'm not here to explain the benefits of a BDA. So taking a step back and trying to understand how this works, and by understanding how it works now, we can see the value of what's coming along now in the future. All of these things we've seen, all of these kind of like features and things we've seen are all based on the idea of this kind of Hadoop distributed processing platform, which I'm sure most of you are probably aware of. And this breaks down, or currently in its current form, breaks down all work into what's called mapping and reducing. So it's selecting things, aggregating things, but it works in a very distributed form. So everything that you run on Hadoop can easily be broken down into kind of pieces of work that can run independently on a cluster. There's no dependency between those items and so on, and it's very easily distributed over an almost infinitely kind of big cluster, really. And again, contrasting, say, with an Oracle database, I know this is a kind of massive, generalization, but the more nodes you add to a rack cluster, probably the less stable it gets. If you had like a 20-node rack cluster, then good luck to you trying to get that running and kind of stable and so on. But the more nodes you put into, say, a Hadoop cluster, then in theory, the more stable it gets. I mean, that's a massive generalization, but in general, shared nothing architectures get harder to run the more nodes you have. And to the fact where actually in Oracle 12.2, there's now going to be a sharding option in there as well, which is, again, in quotes, sort of interesting. Right, so distributed processing and so on and so forth. Now, there's something that made Hadoop much more relevant to Oracle developers and people like me is this thing called Hive. Now, again, I'd imagine most of you are aware of what Hive is. It's like a SQL access layer, a SQL metadata layer, an access layer over Hadoop files to allow people to write SQL-like queries against the data. Those queries then get converted into MapReduce code in the background, and then data is returned to you. Now, this isn't the only way you access data in Hadoop. Typically it's the kind of end stage where you're providing access to end users, or you're doing some form of aggregation or something in the cluster on data coming in. But Hive was the kind of big innovation that all the traditional vendors like Oracle and SQL, Microsoft and Informatica and all these kind of companies then used as the method to kind of query Hadoop data. And as you see here, tools like Oracle BI, Oracle Data Integrator, these can all make use of Hadoop data by using Hive as an access point, okay? Or more recently, things like Impala and so on there. And funny enough, funny thing when you look on the internet, you look up a topic, and you realize you're the only person that ever talks about it. And I did a search on Google a while ago for OBIE and Hadoop, and it kind of, I looked at the results, and every single result was me, which was kind of, either it means I've got that market covered, or it means that I'm completely missing the point here of kind of what is interesting to people. And I think actually it's probably both, really, which is, I think I've covered the topic pretty well. But I think that accessing Hadoop via Hive through OBIE is massively missing the point of what the kind of whole thing's about, because it's incredibly slow to use. I think any customer that comes to me and says, I want to get OBI, Oracle BI, connecting to Hadoop via Hive, can you help me getting it work? I tend to kind of take a step back and think, well, and say to them, what are you trying to do? Because actually it's not really a viable kind of mechanism for doing it, because it's slow, because it misses the point of what it's all about, really. But I'll try and explain as we go on why I think that is, and why what's coming along is going to be a much, much better way of doing this. And in fact, this gets to the point, really, of what most traditional BI and ETL and DW developers think about Hadoop. So if you are how many of you here work with Oracle BI or Oracle Data Warehousing? So a few hands. Okay, good. So I'm in the right room. That's good. So I wasn't too sure whether anybody would be, whether it be, because it's quite a Java conference. And I was thinking I could massively kind of, miss the point of this. But okay. So most Oracle developers who play around with, say, the big data like VM, or they connect Oracle BI to Hadoop, their reaction is well, that's kind of a bit pointless, really. So what people tend to sort of say is, well, Hadoop and Hive, the initial incarnation of it, they're great for kind of batch processing, and that was actually what Hive was designed for. So if you're doing ETL work, if you're doing data transformation work, data loading work into Hadoop, Hive is fantastic for that, because SQL is a great language for doing things like aggregation, selecting, projecting, all this kind of stuff, really. But it's really just for batch. That was the first kind of feeling, and as I'll point out in a second, kind of misconception. It's also just for large data sets. So this again is when people think about big data, they think about taking all of the sensor readers for all of kind of Latvia, loading them in, reading them in kind of minute by minute, second by second, and doing this very kind of large scale work. But actually, Hadoop now, and I say Hadoop in a very kind of like broad sense, also is actually for small data sets now as well, which is interesting in quotes, because that typically eats into the market of the more traditional kind of vendors. It will always be slow because of its reliance on this thing called MapReduce. And if you try to run a query in Hive, through OBIE, it's hilarious how long it takes. I mean, it takes a minute to return the smallest amount of data, and it's absolutely unworkable, really. So to my mind, when people like Oracle say they support Hive as a data source for OBIE, it's just a tick box thing, because nobody in any kind of sense would ever use that. It's just pointless. So why it will always be slow. That's the other kind of preconception. All it can do is map and reduce, because that's what you hear about, map reduce. And Hadoop equals MapReduce, because everyone hears about MapReduce as an algorithm, selecting, aggregating, and so on. And so I think Hadoop is often kind of put down as a animation there. That's why I was up till 2 o'clock doing that. What was I going to say? So there's this preconception again that Hadoop is good, but it's a bit like kind of file storage. You're just going to offload stuff to Hadoop. You're just going to store it there. It's a low-cost archive, and that's all we're going to use it for, really. So that's the kind of conceptions. But Hadoop is slow and only for batch jobs. That's the kind of first feeling people have, isn't it? Okay, well actually, it's not, and it's kind of frighteningly not correct now in terms of a kind of preconception. So if you look at what's coming out there, there's some very, very interesting technologies and things coming along that are completely changing what Hadoop can do. And I would say if I was in Oracle's data warehousing team, I would just be awake at night thinking, how can I keep up with this? Because the amount of open source innovation going on, and the amount of money being put into it, and the amount of kind of like developer momentum behind what's going on is kind of fantastic, really. So there's things like Kudu. I'll explain what Kudu is in a moment. Kudu really is almost like the last nail in the coffin, really, for kind of the supremacy of kind of traditional databases. We've got Spark, which is the latest thing, the kind of hot topic at the moment. Things like Kafka. We've got, where are we here? So we've got Kafka. So Kafka is, well, come on again to what Kafka is, but Kafka is like a messaging system, a data movement system for Hadoop. Things like Mesos. One of the again, we'll get onto these. I'll not explain too much. I'll go through the names, and I'm going to cover what they are as we go on. So Mesos, Tez, and Impala. Okay, so there's an amazing amount of things coming along that mean that Hadoop is not just about kind of batch and slowness. But taking a step back, let's understand what problem they solve and how they solve it. So they say the big innovation in Hadoop when it came out was the ability to break a big job down into little jobs that could run individually, writing the intermediate steps to disk, so that you could distribute the work over almost an infinite amount of nodes, because it wrote the results down every single step of the way. So it meant that if a node failed, so if a kind of a cheap server kind of failed, something else could pick up on the job and run it instead. Everything it did was written down as it went along, and it was slow but very powerful. Okay, so it's like a kind of like a big giant that was almost unstoppable, but you could easily run away from it. And so if you take and this is a pig script, so this is pig Latin. So this is a pig script that you could write here, and this just does some log aggregation from our website. if you ran that through a sort of compiler on kind of an old Hadoop system, then it would compile down into a series of steps that would then get written to disk at every kind of intermediate stage. And you can see, the kind of the steps going on here as it kind of ran. Okay, and this was the original kind of way that Hadoop worked. And so the kind of the resource management platform, which was the Hadoop platform, was inextricably linked with the kind of processing kind of engine, which was MapReduce in Java and so on. So there was no way that anything else could run at that point because Hadoop 1.0, MapReduce and kind of Hadoop were synonymous, really, linked. So what came along next was this thing called Yarn. Okay, so yet another resource negotiator, I think it stands for, and this separated out the kind of the resource management part and the scheduling part from the processing engine. So now we could run different types of workload on Hadoop. So we could run MapReduce, and so a Hadoop system running Yarn can still run MapReduce jobs, but it can run things like Tez. Okay, so Tez is a kind of a swap-in processing engine replacement for MapReduce. And this is backed by a number of kind of distributions. So Hortonworks is, I think, the main kind of backer of Tez, and this allows a Hadoop job, a kind of like a MapReduce job, to run as what's called a single DAG, a distributed acyclical graph. And the net effect of this is that it doesn't have to write down the intermediate steps to disk. So now, rather than, even if you've got a big system with lots of RAM, rather than having to write every single step down individually to disk, it can do it all in memory now. So now we can start to take advantage of all the kind of innovations and all the kind of advancements in hardware and so on. And so the advantage of Tez is that you can just take a Hive script or a pig script, and you can just change. So you can start off by saying, I'm going to run it as MapReduce. So you can go into the kind of configuration settings for Hive, and you can say set Hive execution engine equals MR, which is MapReduce, which is the default. And then if you kind of run that job, this one here, it takes 4 minutes 17 seconds. Okay, so that job took 4 minutes 17 seconds to aggregate all the logs coming in from our website. But if we then swap the engine to Tez, the same script runs. Okay, this is on Hortonworks. I tried this on, and it takes just 2 minutes to run. So the advantage of this is that the same scripts, everything can just run the same, just takes half the amount of time. So it's a bit like the in-memory option for Oracle. You can just switch to Oracle 12c. You can enable in-memory. The code doesn't change; it just runs faster. Okay, and that's in terms of kind of benefit to the end user, to be able to kind of just switch a feature on. It's like the old famous Go Faster button in Oracle that I think Tom Kite used to go on about. Press this button and everything just runs faster. Well, that's what Tez is like. Okay, so Tez is interesting, okay, because it just means the same scripts can run in a lot faster sort of time. However, Tez is kind of interesting because it's completely pointless, to my mind, because it kind of solved, and this is a kind of interesting, there's an article written a little while ago which I thought summed it up perfectly, the tragedy of Tez, which is it's a kind of a perfectly really good thing that's completely missed the kind of the boat, really, in terms of missed the point in how you solve the problem. And so Tez is a project that effectively improves the underlying kind of like, or does what MapReduce does better for certain kind of like languages. So Hive and Pig and stuff like that. But it's, under the covers, it's still got the mechanics of Hive in there. It's still kind of, it's a point solution, really. And so Tez, I think if you're on, for example, Hortonworks, so if your kind of underlying Hadoop platform is Hortonworks, and Tez is there as an option for you. Switch it on, just do it. And you know, typically your Hive queries run faster, your Pig queries run faster, but it sort of in a way doesn't really address the main problem or the main kind of opportunity really. So Tez is interesting, and you'll find these kind of religious wars going on between Hortonworks and Cloudera, and every so often Hortonworks are putting a huge amount of effort and investment into Hive, making Hive kind of fully acid kind of compliant. A year ago, every year our company does an April Fool's blog post on April the 1st, and this year's one we announced that we ported eBusiness Suite to Hadoop. And kind of we did this big announcement on there. One of the things you have to watch out for, it's a bit like with Ask Tom and so on, is because 99% of the time you're being serious, when the one day a year that you're not being serious comes along and you say something, everyone just believes you, which is good in a way because you can have some fun. But so we announced that the eBusiness Suite is being ported to Hadoop, and for a joke I said, and you know, when kind of Hive 2.0 comes out, for the enterprise edition of eBusiness Suite on Hadoop, will allow you to update the data and delete records. And we've had so many inquiries through from people saying they want to buy it, which is kind of good. But the irony of the whole thing again is that actually I bet you in about 2 or 3 years' time we could port eBusiness Suite to Hadoop, because eBusiness Suite doesn't really use an awful lot of. I think last time I looked there was no kind of foreign keys and stuff like that, and so it's probably not the greatest example of kind of data modeling out there anyway. But the irony is probably we could port it to Hadoop in that time, and probably run it on the Raspberry Pi as well, which would be equally kind of, you know, or on the iPhone. But anyway, so Tez is good, but it misses the point really. And the big thing that everyone's talking about is Spark. Okay, so Spark is the future of kind of analytics and data processing on Hadoop, at least for the next kind of like 2 or 3 months anyway, until I have to write the presentation again. But Spark is the big thing really, okay, and that's what every vendor that is launching products running on Hadoop, every analytics project, every kind of platform that's being built for Hadoop around analytics is being based on Spark as the kind of platform. And so Spark is similar, I suppose, in concept to Tez, in that it allows everything to be run within a single kind of a single graph. So, for example, here, whoops, there we go. But it's just so much better thought through. You know, you've got these concepts of what they call resilient distributed data sets, RDDs, which are, I suppose, analogous to tables that you can define, but it maintains a kind of lineage through the system, so that if you have a kind of a data set here and you transform it and you alter it and you do work on it, and if, for example, you know, that gets kind of not corrupted, if the machine goes wrong at some point at the end, it can reconstitute that from the steps that are there, uses lazy execution. It's just a really good kind of platform, really. And so Spark is where the innovation is. How many of you do any work with Spark here? Any of you do any work with Spark? Yeah, so Spark is kind of where it's going at the moment. And so, yeah, my kind of, in terms of my team back in the office, you know, this is what we develop in now. This is the kind of direction that we tell staff to kind of to learn and to do things with. And also Spark has a number of kind of spin-off projects as well. So Spark SQL, Spark Streaming, Spark ML, that I'll explain as we go along as well. But Spark is kind of where it's happening. So with Spark, you typically program it in a number of languages. So, you know, Scala, which is the one that we use, Python, Java, and so on. There's an API that's the same across all the different, well, more or less the same across the different kind of languages. I suppose the thing that is the biggest kind of learning curve, or the biggest kind of hurdle to working with Spark is, you know, for example, learning Scala. And Scala is an interesting language in that it's sort of based off Java, or uses some Java kind of features and so on. But it's very much, it's natively very good at doing the kind of functional programming and the distributed work that we do in Hadoop. So Scala is an interesting one in that it really, more than anything, really kind of you benefit from just taking a step back and doing some reading and actually studying it before you start doing it. I think, you know, to try and just hack your way through Scala without ever reading the manuals or understanding the kind of logic of how the language works, you're going to get in trouble after a while, really. I think it's, you know, for me, I had to, at some point, I'm the kind of quintessential kind of hacker, and I was trying to go through there looking at blog posts and trying to read stuff, but I had to take a step back and just read through this and understand some of the concepts behind how Scala works. But Scala is also what Spark is written in as well, so it helps to be working in the same language. So Spark is going on, and I'm going to cover as we go on some of the stuff that's coming out of that and supporting Spark and some of the spin-off things like Spark SQL and so on. But also under the covers, the underlying platform that Hadoop runs on. So again, Hadoop, people tend to think of it as being MapReduce, as being HDFS, as being all these kind of things. But Hadoop is almost like more of it's just a concept really, or a kind of an overall framework. So the underlying file system, the distributed file system that you store data in, which is very Unix-like and it is stored on files. There's something called Tachyon, which I think has been renamed recently. Tachyon is like an in-memory version of it. So if you've got Spark running in memory, which is its main kind of benefit compared to say MapReduce, then it makes sense to have an in-memory file system. And so Tachyon is that. There's also Mesos as well. So Mesos is a resource management framework, so resource management, and in fact, anybody in this room who is an Oracle developer, who works on a shared Oracle database knows how hard it is to do to share resources and fairly distribute resources on a kind of Oracle system. And this is a system that I remember I worked on an Exadata project a couple of years ago with Martin Woodlake, one of the guys who's on the scene as well. And it surprised me even then how hard it was to isolate a data warehouse workload from a BI workload on an Exadata machine that had an Oracle database on there that was version 11. So think about how hard it is to do this on version 1 of a lot of these things. But Mesos is very good for scheduling things as services. So with a a guaranteed response time or very fast response time, not just these kind of high, really big but slow batch workloads. And so as well as it being in memory, we also have real time. And so most data feeds into Hadoop are real time. And so in fact, the default method of loading into Hadoop is real time, which is the opposite of data warehousing, really, where we tend to do a batch load. In fact, we do a one-off load at the start. Then we might gradually, go to a daily batch or a hourly batch. But real time is this big deal that we have to really think about how we're going to do this. So we try and convince the customer, do you really want real time, or do you want near real time or stuff like that? Hadoop is typically always real time, and any batch work is maybe to supplement that data with some reference data from say an operational system. So how do we do that? In the past, we've used Flume, and we use Flume a lot for doing this. So for bringing in data from say weblogs or websites or whatever, we actually now use Golden Gate quite a lot. So Golden Gate is an Oracle product that can load into obviously lots of things, but one of them is Hadoop. So we have customers, and in fact, the session I'm doing at 17:45 today is on data reservoirs and how we can use a Hadoop data reservoir to bring together all data from all different systems to do things like customer 360 analysis. And so Golden Gate is great for doing that because we can take transactions from Oracle, for example, or SQL Server or whatever, and we can load that into Hadoop as well. We can integrate it with Flume, or we can integrate it with Kafka, which is the other thing that's interesting, one of the many, many things that's interesting on this platform. And so Kafka came out of LinkedIn, and Kafka is rather than the point-to-point integration that we get with Flume, Kafka is more like messaging, like a message bus. So we can bring in events and log items, maybe things like Oracle transactions, or we can bring in things like events or log items or whatever, and we can put it onto the Kafka bus, and then we can distribute it to lots of places. It's very resilient to the point where it can almost be a platform in itself. And one of our ACE Director colleagues, Gwen Shapiro, works there. We know them quite well, Confluent, and it's a good platform. Again, it's open source, but it's very good, very interesting. And then the other part to all this is how do we then process this data coming in? So notice the theme here. We've gone from being batch-based, which is what people thought Hadoop is about, to now being real-time loading. Okay, we've got real-time processing. And we've now got Spark Streaming, which is the same code base of Spark, but allows us to actually process data on the fly So, we use this back in our company, and I think we cover this in the session this evening or tomorrow, to actually kind of spot interesting things happening with our web activity and tweets and so on in real time, and actually correlate that with stuff, do sessionization and so on. So it's all real time and it's all kind of processing. But, okay, so you're kind of good so far. It's all real time, it's complicated, but it's kind of interesting. So, but Hadoop development is only for Java developers. And so this again was my concern when I got into this, because my background is not in Java development, really. My background's in SQL, PL SQL, all this kind of stuff. So Hadoop is only for Java developers. The answer is no. There's a lot of stuff, and you hate to admit this, and you hate to kind of like to say, okay, you might have been correct, but there was Oracle a couple of years ago was saying, SQL is the kind of the lingua franca of Hadoop. And I was going, ooh, no, you would say that, wouldn't you? You would say that. But they're kind of correct in a way, in that, much as it kind of pained me to kind of yeah, okay, right then. So SQL, because the reason I kind of was skeptical is because when the Hadoop discussion was all about kind of unstructured data and Java and all that, it's quite hard for Oracle to be relevant, I think, in that kind of discussion. But as soon as the discussion is about SQL, suddenly Oracle is relevant again, And so my feeling was, well, you would say that, wouldn't you? But actually, the market has been slightly validating that, so I'll give you that one. So, but what's interesting is it's not SQL as we kind of know it, or certainly it's taking the idea of SQL and taking it further. So we have things like Cloudera Impala. So Impala is a kind of a distributed, fast query engine for Hadoop data that is kind of split-second response time, very, very fast. It shares some of the Hive kind of features. It shares the same metadata dictionary and so on as Hive. It works in a similar way to things like Netezza and Teradata, in that you have a distributed kind of set of kind of nodes that kind of run things and so on. Impala is probably the kind of the simplest, quickest, easiest way of getting queries to come out of Hadoop fast without having to massively change how you do things. And so a lot of our customers that come to us and say, can you get Hive working with OBI? We say, well, we can, but how about we get Impala working with it? Because Impala is probably a bit more of a kind of a relevant solution for you. And so you can just go into Impala, into the shell. You can just query Hive tables as they are. They're just faster. So it's just really good. To the point where if you're running an OBI query using Impala, it goes from, say, 50 seconds for a response to 2 seconds. So now it's usable. Okay. The disadvantage with Impala is it's not kind of full SQL. It's not as full as you expect to see, particularly compared to, say, Oracle SQL. So another solution is Oracle Big Data SQL, which is something that was a great product that no one could ever use, because it used to have such a massive set of prerequisites that only kind of like Larry Ellison could ever use it, because it required you to have a BDA, an Exadata machine, an Exadata bumped up to the correct version. It was such a ridiculous set of kind of prerequisites that I think Larry Ellison and Dan McClary were the only people that could ever use it. So what's happening now is that my understanding is that those prerequisites are being kind of taken away. So you'll have to use a more recent version you have to use the most recent version of Oracle 12c, but you can use a commodity cluster. So you can use just Cloudera or Hortonworks running on your own cluster, and so on, really. So Big Data SQL, I would hope we'd see a lot more use of, really, in the future, because it's really cool. It just lets you run Oracle SQL on Hadoop, including Smart Scan, all that clever stuff. So this is kind of fantastic, because if you can do this, then it just means that your users can just kind of query this and query your Hadoop data just like it was Oracle data. This is, if you can afford it, this is your perfect solution. This is fantastic. But it's not open source. You have to have an Oracle 12c database and so on. But if you can do it, go for it. This is perfect. Another thing out there is interesting, is called Apache Drill. So Apache Drill is it's kind of as a nuanced kind of thing here, but Apache Drill is like a schemaless SQL engine. So it allows you to take a file. So as long as the file or sets of files has got some implicit kind of like metadata in there. So if it's, for example, a Parquet file, and Parquet is a storage format that has some form of metadata in there about columns and so on, because it's column storage. If it's a JSON file, all these kind of things, it can infer that from the file, and you can query it as if it had had a schema there. So this is really cool, and you can just download it, point it towards a file, and query it like SQL. This is kind of really interesting. And then you've also got things like Hive on Spark. I'm conscious of time, won't go into this too much. This is porting Hive as an execution engine porting Spark as an execution engine for Hive. But typically we use something called Spark SQL, which is a SQL engine within Spark. Again, Oracle, okay, all you right here. This allows you to kind of run SQL. This is like running SQL in PL SQL. So if you think of Spark as being PL SQL, Hive SQL is like being able to run, actual SQL within PL SQL, which and we all know what that benefit of that is. So that's really cool. And so you end up with these different types of SQL engines that you can use really for different kind of like circumstances. And then also we've got now column storage. So Parquet is a column format, column orientated storage you can get now within Hadoop. That is, it stores data in columns rather than rows, which, as we know from the memory option and the column store options in Oracle, is great for analytics. To the point now where we have something called Kudu, which is basically the end of anyone's support contracts with Oracle, because if you're doing a data warehouse, because the problem with Parquet is that it doesn't really support streaming workloads, because the way it kind of does the columns and does storage and compression doesn't really support streaming workloads. But Kudu supports both streaming and fast queries. This, to my mind, is your 22% support and maintenance fee being spent on a trip to Vegas rather than renewing next year, which is kind of interesting. And this is the existential kind of like threat that Oracle's DW team would have. Almost finished. I'm conscious of time. But it's insecure. Okay, that's the last argument. But Hadoop is insecure, and absolutely 100% correct. When you install a Hadoop cluster out of the box, it's ridiculously insecure. And when I tell customers that you can just spoof a login, you can just kind of say, I am Chris Saxon. I'm logging into the Oracle kind of Hadoop cluster. And it goes, are you Chris Saxon? I said, yes, I am. He goes, all right, there you go. And lets me see everything in there. Okay. It's ridiculously insecure because it doesn't use anything like Kerberos or anything at all to kind of, unless you enable that. Okay. So you have to actually go and enable things like Kerberos authentication before it becomes secure in that way. The other thing is, and this is kind of laughable, that the default kind of security is on files. Okay, so you end up with this situation where if you want to do kind of role and kind of departmental style kind of security, you end up with this profusion of files you create for a file for almost every combination of role and department and access level and so on, because all you can do is do POSIX style kind of security on that. So there's been things like Sentry that have come along. So Sentry is a form of kind of role-based access control over Hive. But again, an example that was good here is Big Data SQL. If you've got this, you can extend Oracle security over Hadoop. That's one answer. But the other thing here is this thing called Record Service. So Record Service is another thing that's coming along, which gives you a consistent sort of like authorization schema across all Hadoop data, including files, and it means that we can start to get the same level of kind of like consistent security and fine-grained access control that we're used to with, say, Oracle. And the last bit I'm going to say, I'm conscious of time, predictive modeling as well. That's the last bit really that's interesting. There's a thing called Spark ML. So this is machine learning that's used, that is a bit like R, a bit like stuff like that, data mining. But this is the algorithms implemented in Spark. Okay, so we can actually do things like clustering, regression, all that kind of stuff on the fly with streaming data. We can do it clustered and so on. And in fact, Oracle themselves are building all their big data products off of Spark. And there's one example that's actually out there now, which is Big Data Preparation Cloud Service, the most boringly named product I can ever think. Apart from what was the backup device they had? The Oracle Secure Backup device that was, it's very literal kind of naming, isn't it? Really, it's like I'll tell you my analogy at some point as well with naming, but it's but they use Spark ML to automatically classify data coming in via files and suggest to you what the name of the column should be, and actually identify if it's got, say, secure data, well, got what's the word? I think got credit card data in there as well. So it uses this thing called word to vec in the background to classify data, which means that as an ETL developer, you can go to the pub while this does all the work for you. You come back and it's done all the classification, it's done all the kind of obfuscation for you, and you can tell your boss that actually you did it, but in fact it was done for you by Spark, which obviously is not bad, as my friend here would kind of say. So I guess my point really is there's a lot of stuff going on in Hadoop, and don't dismiss it as being just this kind of batch-based, very slow Java kind of platform. There's some very kind of clever stuff going on in there. And excuse me, as Oracle developers, I would say it's absolutely crucial that you understand this stuff, because I think not the same with OLTP, not the same with kind of like transactional stuff, but with kind of data warehouse and analytic workloads, this is where it's all going to go. You know, I cannot see any reason why you would use anything other than this for your workloads in the future. Now, the great thing about it is it can interoperate with Oracle. You know, you can use Oracle are extending it and they're kind of enhancing it and so on and so forth. But the underlying platform is fantastically innovative. It's in memory, it's fast and all that. And this is kind of where my career is going. You know, this is kind of what I think is interesting. So a lot of stuff there. Anyone using any of this stuff at all? Anyone using Spark or stuff at all for analytics? Anybody? Yeah. Any questions at all from anybody? Any sort of thoughts or observations? Yeah. By the way, when you ask me a question, you have to think of that, okay? Because it's not bad. Okay, that's the kind of thing in the background.
It's very good. The same question. Can you elaborate a bit more? How is this OBI connected to Impala?
Yeah.
Is there built-in driver? Do we need ODBC driver? And particularly, what happens if we run OBIE on Linux?
Good questions. Okay, so what I'll say to that is I'm doing a session tomorrow between 9 and 12. And that's what I'm going to do in the session. So today is more about concepts, but in tomorrow's session, 9 till 12, we're going into the detail of how we do this. So we're going to go into how we connect OBI to Hadoop. We're going to go into the detail of how we connect ODI to Hadoop. And we're also going to go through things like graph analysis with Oracle Big Data Graph and Spatial. So all the detail of how we do it, come back tomorrow, and then we're going to do it tomorrow between 9 and 12, because it is getting into the weeds, but we'll do that all with demos tomorrow. And if you want to see how that stuff works and play around with it yourself, if you download the Oracle Big Data Lite VM from OTN, that's what I'll be using for the examples tomorrow. Okay, so we'll cover that tomorrow. Thank you. Any other questions at all? No? Okay, thank you.
No more questions, please. After the session, remember about voting device. You can use it to vote.
Just press the green one. Green, that's it. That's the one. Thank you. Cheers.